right. So you're from Runcom?
Runcom, an Israeli company.
Yeah.
It's a small company, 90 employees. Most of them are engineers, develop R&D. Our contribution to the WiMax is the OFDMA. It's our invention, and we are in this business for quite a lot of years. In the past, it was more for products like DVB RCT, which is two-way video, interactive video. But then this standard didn't catch cold market, probably because of frequency allocations. And lately it was evolved into the WiMax, which uses the OFDMA.
Can you explain the OFDMA?
Just click OFDMA on the web and you'll find it's more mathematics, and it's standard. On the air, it's the physically it's more suitable to environment like reflections when you have on dense city area while you're moving with your mobile.
All right.
And it's a really solution for mobile environment. The standard is called 802.16e.
Yeah.
It's everybody knows already the 16D. It's just a small letter, but it's really a big change.
So OFDMA, it's only E.
It's only E. Yes.
Only E.
Yes.
And that's mobile.
That's mobile. So with a product like this, that's just a reference design that we make.
Yeah.
Our chip is inside. We are fabless. We are doing the basic defined macOS of the chip, a baseband chip for both base stations and this user terminal. You can simply plug it in your in your laptop or PDA. If hopefully you have a service provider around, you can have a stream. Just look at this. This example, it's 1 megabit downstream with high quality video. It's not those small tiny pictures, images.
Full screen video.
Yes, it is not video. It's not a traditional video broadcast. It's IP, a real IP platform. And you can have any application in parallel. You can have voice over IP. Just like your PC. It's IP. Everything is open.
So there you're streaming from this camera over there at your booth.
Yes.
Down there is a small camera.
Yes.
And you can walk around with the laptop.
Yes, we can have. If you want to have.
How many kilometers?
In this hall, we can go to the most extreme ends of it. Yeah. It's a very low power right in here. Outside, there are some theories, some field trials right now in Korea.
Could we just go outside just to one?
No, it won't smoke out. I don't know why something blocks it, but we can go far away from here in this hall.
We could, but we don't have to.
Yes.
Okay.
We can go, I think about 100 meters, 200 meters in this hall.
All right.
And we also have more sexy devices like compact flash card to put in your PDA.
So all that is WiMax?
It's mobile WiMax. Many people saying WiMax, but they mean the D standard, 16D. This is mobile. Mobile. Yes.
Well, can you show some other small things you have, or?
Okay. We have that's. I don't know if you can take a photo of such a screen. That's a real drive test in Israel.
So this is a computer with the WiMax inside?
Yes. This is just a playback of a video that we recorded while drive tests in our country.
Okay.
Maybe we can do it from the beginning, because there it's a description of all the...
No, basically you're driving around?
Driving around the town.
With the camera?
With the camera, both two ways, both from the vehicle to the base and from the base to the vehicle.
Alright, so it's like you could also do video conferencing and everything?
Yes, it's IP, do whatever you want.
Whatever you want.
Security, survival, any application that you want.
How is the latency compared to if you're standing next to the modem? What's it called?
Right now, the latency, we have some latency here just because of the laptop processing time.
Yeah?
But there's no...
Vibro? So Vibro, that's what they call it also in Korea?
It was the three. I mean, WiMax, Vibro from the beginning.
Bidirectional.
Yes, Vibro is just another profile of the 16A. WiMax
Yeah.
is one, Wibo is another.
Yeah.
Some small
Of the E.
variations
Of the E1.
Of the E1, yes.
All right. So you can actually make the chip that goes in a PDA.
Yes, yeah, look, I can show you the chip. It's really tiny.
Yeah?
It's a very powerful chip with ARM11 processor inside.
Yeah.
90 nanometers. It's very advanced,
All right.
and it's
19 nanometers. That sounds like the chips they do at Intel, but
we think we are ahead of Intel, but they might be our biggest competitor.
oh yeah.
Yes.
So, can you just say, like, Intel, do they also have something that small for PDAs? Or not yet?
We know exactly what Intel has. You'll better ask them. They will tell you.
Okay.
Okay.
Maybe. And the PDA, can we show this one?
So
This one has built in?
that's a product of Samsung.
Yeah.
They already in June this year they are going to implement field trials, or actually a commercial service in Korea. Some
First micro in the world.
Yes.
Yeah.
And all the world is expecting this.
So from this machine there, you can download at 3 megabits per second, or what is the speed?
Look, there are many. Depends on the service provider. He can he can define for each unit what is the quality of service, what is the bit rate. The spectrum is dynamically. You can within the spectrum allocate more bandwidth to the upstream or to the downstream as you wish.
So everybody shares the bandwidth on a sector.
Yes, correct. But you, according to the level of service that you commit to your customer, you can deliver in whatever you want. The modulation is adaptive. It means if you're far away from the base, the bitrate is going to be lower. The modulation scheme is going to be more rigid. So it's always trade-off between. It's a dynamic trade-off between data rate and distance.
So I mean, you're proving that it's already in the size of a PDA, no?
Yes.
Yeah.
Yes.
Because when I was out working around, some people say it's not yet in a PDA.
It's not embedded yet. We've started working with some manufacturer. As Wi-Fi is embedded inside your laptop.
All right.
So we've started working on such a product.
All right.
Right now we really sell to operators who want to learn the technology, to play around with it. Also for developer, complete standalone base station as you see there.
Yeah.
That's what is working right now in this booth. Hooked to a small antenna, transmits all around, and being received by this PCMCI card
That
to your laptop.
Yeah.
Or if you want a set-top box,
Set-top box.
you can have a set-top box
Yeah.
with all types of interfaces, USB, SDIO.
All right.
You have PC card, Ethernet. You can have here also some for authentications, some
SIM card.
SIM card for authentication. So this is just. It's not a mass production product. It's more for evaluation and field test.
But you're not gonna do the mass production yet?
No, we are concentrated on the fine MAC layers on the baseband chipset.
Yeah.
We don't want to go into production.
But I mean, this Samsung one is a mass production, no?
So we sell them our chip. That's all.
Oh. All right. That's all. Okay. But how about so this box there? Could you put that in a village and they would have like broadband for many people?
Yes, it can be used as a fixed link to remote areas. We connect it to maybe a local Wi-Fi service, or it can be directly. It can be.
Could you plug this together with a Wi-Fi router and then everybody can?
Yes, there are some manufacturers that are interested in such configuration.
Yeah.
I would like to see this as part of IP phone. Today you can find the IP phones with Wi-Fi.
All right.
Let's have it both Wi-Fi and WiMax together.
There's no problem. They can be both in there.
Right now it's difficult to put it on the same chip.
Yeah.
Because the Wi-Fi is OFDM. This is OFDMA. It's quite different. But
could you have two chips in the phone?
Yes.
Yeah.
Yes. Like there are some thoughts about maybe, just imagine everybody has some mobile phone in his pocket already.
Yeah.
No one would like to have one more on the other pocket. So maybe there will be some in the first stage, some units with GSM phones together with WiMax chips
WiMax,
together.
yeah.
Yes.
All right.
So we are proud really to bring the world the first ASICs for headsets.
And the small antenna that you need in the phone is just a normal small antenna?
The antenna's size is just set by the frequency range.
Yeah.
So if it's going to be something around 3.5, 2.5, it's higher frequencies that are being used for cellular, so the antenna is going to be smaller.
Yeah.
From engineering point of view, from communication point of view, the lower the frequency, the better it is.
Okay.
So there are some thoughts and some markets for military applications where the soldier will have a badge inside the uniform with some communication devices, and they may be really interested in lower frequencies like VHF bands, UHF bands. So it's.
And the battery consumption is the same as the Wi-Fi, for example, or?
Battery consumption is a really important issue. It's it depends on the application. The standard requests, the standard defines that we support sleep mode, idle mode. On these phases, the equipment consumes just milliwatts, nothing at all. But when you have real transmit receive with high bit rate, the power consumption can go up to half a watt, 0.8 watts.
Okay, so can you, for example, have a phone that is sleep mode and you can receive a voice over IP call?
Yes.
But it can last for, at least the whole day.
Well, I don't have such a piece in my hand, but that would be. No one will be satisfied with less than less than the 1 day battery.
So if it rings, like when you receive an email or when you receive an instant message, it could do that for at least for the whole day.
Yes, but if you're going to watch TV all day, I won't believe it will hold too much.
Okay.
We're already supporting head-off. It means if you have two bases, you go from one base to another seamless.
Right.
Without losing any data, without disturbing the video or audio quality. It's well defined within the standard, and we support it.
All right.
And now I think there are many places in the world where they want to deploy fixed services with the 802.16d, the fixed WiMax. And now that we introduced this mobile one, then all the operators, integrators now hesitate whether should they stop and go to this. But on the other hand, we have cheap. There's not much selection of equipment manufacturers. So it's some troubled phase for operators to decide.
So the operators who use the F, they might, what's called D, they might have to upgrade a few months later.
So they will better wait or look for the E.
All right, look for the E. Okay.
Yes.
Okay, thanks.
You're welcome.
Thank you.